This short screencast is showing you about R as an object-oriented program. I hope it will just help you to get a bit of an idea about what R can and cannot do, and some of its amazing capabilities. So what is OOP, object-oriented? It's something where I'd like you to sort of understand that we can have different forms and sizes of pieces of data, really. You can have things like a constant, you can have a list of items, you can have a matrix, you can have a more than two-dimensional matrix, which is called an array, and you can have a data frame. Also, when we undertake an analysis, we have some output. We might do an analysis of variance, we might do a statistical test, and we get an object in R, which we can then sort of query to get more information out of it. So it's really powerful. One of the wonderful things about OOP is the power. It might only be a simple mean or a minimum, but anything that we get out is sort of considered an object. So let's just see some advantages. As I said, it's a very powerful statistical tool. We can use the objects for plotting, displaying. Occasionally we want to get residual plots out from a model. We can easily do that. When we run an analysis, we produce an ANOVA object. And with that object, we can use lots of outputs that we need to report on the analysis. So let's just help you to understand what they are. So this is just a visual where on the left here we've got one value. It's a constant. It might be the slope, or it might be something that we just are using as a constant in the formula, or so on. The next thing to think about is you can have different types of data. You might have a continuous variable such as 2.3, or you might have a categorical variable where you've got male, female. So that's just to remind you that a number can be a category or a number. Sometimes when we're doing factorial analysis, we might have different varieties. Those would be given names. We can also have a list. So here in yellow, we have a list. Those are all numbers. They all have the same type of data, and it's just one vector or a list, and that's another object. So here's some more objects. So moving on from, we talked about variables, lists, let's think now about if we had a matrix of numbers. So a 2 by 6, here's a 2 by 6 display. This is a matrix of numbers. We don't really know much about it at this stage. We could also have something that has more than 2 dimensions. So for every 34 and 4, there might be another list of 10. So that would be a multi-dimensional or an array. We won't worry too much about this. It's just the concepts that are really important. Here, we're now moving on from just having a matrix of data to, in fact, a data frame. Now, this is more what we're probably used to seeing. We have a spreadsheet, we have a plot ID, we have some variables on yield, which are numeric, height is numeric, we have varieties, and we might have something like a category, whether it's insect resistant or not. So in a data frame, there's two things. We have different types of variables, different columns, and we also have a header which gives us names. So let's just have a quick look at this header. One thing I'd like you to notice is the names I've given it, and I'll talk about that in a minute. This is plot ID. It might just be called ID. It might just be household if it was a survey. This is just showing you that in R you can have plot.id. That's a quite valid variable name. We can have something called yield. We can have something called height. You can use capitals if you like. Here's variety. And we've got the ABCs here distinguishing between our varieties. If you wanted to make something a little bit more intuitive, perhaps, maybe this is about insect resistance. So you can't leave a space because R won't like it. So you need to go insect underscore resistance. Okay. So lastly, the last type of objects we have is that if you fit a model, then we have an object. So we can query or get access to many parts of the ANOVA from the object AOV, analysis of variance. And when we do linear models and other types of models, we will come across other models which we can actually name ourselves. And in more complex analysis, you can compare different models. Like you can fit a more complex model or a simpler model and do that comparison. And these will be explained in the course, but I'm just mentioning it here. The structure of a data frame is fairly important for simple experiments and simple studies. So one thing everyone should hopefully know already is a row in a data frame is usually one experimental unit in a trial or one person in a survey. Or if it was a household survey, it could be something about the household. So you can see already you've got to think a little bit about what your data frame might contain. The column is typically used to denote the variables. Some may be a simple ID, which just shown you. Some are required to show the structure of the design. In a blocked analysis of variance, you might use a block. And some variables are what you've measured. You've measured height, yield. You've categorized it as whether it's insect resistant or not. Quick note on variable names. This is always important because when you're learning a new package, you need to know some of the rules. So these are all quite okay. If we had a variety, we could call it a variety. This would be like a header row. We could have it variety. We could have it as B1. We could have it as junior type _1. That's fine. We could have BAR.1. They're all completely acceptable. But we do not use spaces, as I mentioned before, and we do not use characters such as stars, ampersands, percentages. They're not compatible with the statistical software, and even in other software packages, it's always advisable to try and keep your naming conventions fairly straightforward so that you don't run into problems when you're bringing your data in. So just at the bottom here, we could not use one var, and that's because it starts with a number. We can only start with an alpha or a dot. And we couldn't use var space 1 because it's got a space in. We couldn't use junior type 2 star because it's got a star in. So they're all things just to note. It's rules. Here's some naming rules. The variable names can start with a letter or a dot and not a digit. They can only contain alphanumeric characters, so they can contain letters, they can contain numbers, they can contain the underscore, and they can contain a dot. Another small tip, do not use T or F, as these variable names could easily get confused with true and false, and in some of the programming in R this could cause you some problems. And I would say not only don't use it as a variable name, don't also use it as an item within the data. So don't have a column of T and F. It might be better to use a 0, 1. Here's some R code, just to give you a very heads up. If you don't want to go any further, you could stop now. But here I've got, this is part of a file, and I'm just putting on the top a comment. X can be a constant. And I'm showing you here how easy it is to assign 34, which is my constant in this case, and I want to give it and keep it and store it as an x1. Here we've got like the left sign and the little dash. That together, so there's two keystrokes there, is called the assign. Very, very important. So we, in this top one here, are assigning 34 to x. If I then, so this is making 34 stored as x1, and I type x1 out, I actually get, this is what I get back in the log. It says that it's one element and it's 34. And as I said, your x, the object, so we're now talking that's x1, the object is a constant. In this case here, x is going to be a list of numbers. And the way I can easily do that is I can use this assign again, and I can use this C, which you can think of as combine. I'm going to combine these 9 numerals, one separated by a comma, that I'm going to assign that to x2, and then I type x2 and find out what's there, and I find that I've got a list. So my x2 is made up of all of these variables, and this is saying this is one element. Likewise, down here, I can have another object, and I might in this case want to sort of, I'm looking at, say, people's favourite colours. They could be red, blue, green, whatever. So if I want to combine strings, these are called strings because they're text, we can combine it very easily like this, and we assign it to x3. We then say, what is x3? And we get the answer, red, blue, green. Wonderful. And lastly, I'll just show you here a little bit about a matrix object. Don't get too worried about this code at this stage, but I can just show you how easy it is. So you can concatenate or combine 4 numbers, and you put it into x4. So in fact, that starts out as a list, but then if I want to make it into a matrix, I can do this by saying combine row 1, row 2, and this is just naming. This is the naming. The red is names. I'm going to call those row names. Likewise, I'm going to do C, C1, C2. I'm going to call those column names. And then you'll see there's a little bit of trickery here. We're going to, here we've got our list. We're going to make that into a matrix, which is x5. So then we assign by using the word matrix, using x4, which is this, and we're saying the number of rows is 2, the number of columns is 2, by row equals true, and then we just tell it the names here. This is just saying the dimensions of the names are the list of the row names and the column names. So this is just a bit of code. You don't have to remember it. If you ever wanted to do a matrix, you could use this. And then when you type out X5, you actually find that you get a little matrix coming out. So likewise, you could actually make that as a data frame, and you could just say, okay, I want that matrix, and you can just use this as data frame of X5, and then it goes into a little data frame called X6. So maybe in your own time, you might like to just consider what the characteristics of these variables and objects are. I'm not going to fill this in, but for instance, a constant is one fixed value, and you need to think that you can understand what a list is, what a matrix is, what an array is, and what a data frame is. But this will all become obvious as we go through our course. And lastly, I just wanted to show you a little bit of extra code here. Let's use a command to look at all these objects. So I'm using a command here just called structure str of object 1. And you remember we had object 1, and it tells me it's a number, and it was 34. That's wonderful. Then structure 2 is a list, x2 is a list. So I do structure x2, and it returns it's a number 1 to 9, and it gives it to me. Okay. Likewise with x3, when we had our characters, when I ask for the structure of x3, it tells me it's a character. It says there's 3 elements, and they're called red, blue, and green. And the structure of x4 again, originally was a list of 4 numbers, so we get numbers 1 to 4, and there they are. So I'm not going to go any further now, just to give you a highlight. The next steps are that when you get into a little bit of confusion, you might recall this information. If you do get confused, if you get a funny error message, or if you've overwritten one of your items, it might be that you've forgotten the name of something. And there will be more tips on using R as you go through the course.